vectors are. So if you look at this page, vector is characterized by its magnitude and its direction. So it's kind of like an arrow. So this arrow, the length matters because this arrow doesn't mean that it's going to keep going on forever and forever. Okay, it just means that the direction it's going and the length is represented by something called a magnitude.
Ms. Yannard, is the same
Yeah.
vectors that are used in physics, or is it
Yeah, I
different?
think so. I think it's the same thing.
Oh, okay.
There's only one word, but I'm only teaching like the basic forms of vectors right now. So let me see. Okay, and if you look at this, this is really similar to polar from last section. You still have like the length. Like if you look at where the V is at, that kind of looks like a polar, when we draw polar coordinates, we have a point, and then we go to the length like this. Okay, so that means your R from last section, it's the same thing as the magnitude. So I'm gonna go to the next page. I don't know why it's lagging. Okay, so to find the length of the magnitude, you just gotta do the x squared plus y squared, and you take the square root of that, which in this case is a and b. Then we take the square root of them, add them together, and take the square root. That would be the length of the magnitude. And the reason why we have these absolute value is because it's a length, so it always has to be positive. Okay, and then direction as well. Direction, you just have to do the inverse tangent, and you put the y value first, and you put, which is right here, and then you put the a value next at the bottom, which is the x value. Okay. So I also showed you guys some examples down here, which is find the magnitude and directions. So I'm gonna have you guys try to do it right now. Follow exactly what I have in this example, and then you guys do it for number 2 and number 4 for your homework. Let me open up a new page. So for your homework, number 2, you gotta find the magnitude of -5 comma -2, and number 4, you're finding the direction. So write this question down. And then I'm gonna have you guys try to figure it out using this example. Okay, and then once you are done with your answers, please send it to me in the chat so I know you are participating. I have a lot of you guys in the chat in the meeting right now. So yes, just send me your answer and then I'll tell you whether it's correct or not. Please do this right now in the next 4 minutes. Okay, I'm gonna write the question again. Number 2 is magnitude of, what was it? -5 comma -2.
the digit do we round to?
You can leave your answer in square root form if you don't have a calculator with you. For number 2. Mhm. Let me see. I'm getting a lot of answers. That's good. If you guys don't have a calculator, you can just help me square root of whatever you get right there. Okay. Okay, so good answers. Okay, so I'm gonna go over the answers. So for the first one, I don't know why there's a lot. Okay, oh well. So I'm gonna put -5 squared plus -2 squared. And the first one, well, when I get this together, it would be square root of 29. And if you put it in the calculator, you should have gotten 5.385. Okay, if you say 5.4 or 5.39, that's correct. Okay, and for directions, we're going to take the inverse of tangent of -2 over -5. And the answer to this, let me see. If you put it in the calculator, you probably have gotten 0.38 as the answer. okay? But then this answer right here is actually pointing towards this direction, okay? The question that we have right here, oopsie, this one, -2, -5. We want it in this quadrant, in the third quadrant. Okay, so we want it to be pointing towards the opposite direction. So I have to add pi to this answer. So if we add pi to this answer, it would be 3.52. Okay. Any question?
Why'd you add pi to it?
Because if I have 0.38, okay, if you put it in degree form, I'm gonna put it in degree form for this question. It'll probably make more sense. Inverse, oops. Hold up, I'm using my calculator. Okay. If I put it in degree form, it's 21.8. And I know -5, -2 is not at 21 degree. Because 21 degree is right here. 21.8 degree. -5, -2 is somewhere on this side. Okay, so I have to add a 180 degree so it to be on the opposite direction. And another word for 180 degree in the radian form is pi. Okay, so if I have to add 180 to this, that's the same thing as saying adding pi up here. Okay, so I hope that answered your question.
Yeah.
Yeah, okay. Okay, so that's it for 2 and 4. So go back to, let me see. Let's look at the rest of the notes real quick. Okay, I'm gonna go over what it's factor addition and factor subtraction. Whenever you have two factors adding together, it's just as easy as you add the first number to the first number, and then you add the second number to the second number. So it's A plus C, and then B plus D. Okay, and then for the picture, I'm gonna erase this part first. Okay, so let's say if I have a U vector and a V vector, you always start them off at the origin, okay? But then whenever you want to add the vector together, we have to line up one of those vectors. So usually I take the second vector, which is V. I put that up here again. It's exactly the same length. It doesn't really look exactly. Let me do it again. So it'll look like this. Okay, so it's exactly the same length, and you put it at the arrow of, your previous one. And then your final answer would be going from the starting point to the end of V. So this length right here is called U plus V. Okay. And then same thing at the bottom one. So this green line and this purple line was what's given. Okay, these two lines were given. So if I have to draw my U plus V, I have to redraw my V to touch the end of U. Okay, which I redrew it right here. So once I have them kind of connected, I start from the origin again, and then I go all the way to V. So this line is called U plus V. Okay? And then for vector subtraction, So it's really just same thing. You take your first minus your second number, or minus C, A minus C, and B minus D. Those are my, like computation way. That's how you do it. And then if I have to draw it out, you don't have to redraw it, because once I have my U, once I have my V, to get the U minus V, we start at V. Okay, start at the end of your whatever you're subtracting to, and then we arrow it back to U. That would be U minus V. Okay, and I wrote it down there too. I said start, to get your U minus V, start at the arrow of V to the arrow of U. Okay. I think I also shown an example right here. I showed two examples. So I'm just gonna talk about one of them. And then if you want an extra example, you can look at the video later. So U plus V, again, these were my questions or vectors. And then if I have to add them up, I just do 1 plus 3 and 2 plus 1. So I get 4 comma 3. And then picture-wise, I start drawing my U, start drawing my V, which is right here. Okay, and then I redraw my V. Okay, this is V. And I had to redraw my V up here. So then I can connect the arrows, or connect the beginning, the origin, to the arrow of V to draw U plus V. U plus V. Okay, so I'm going to write the question of number 8 and 10. Hold on to number 6 first. Number 6, I'll do it for you guys, with you guys. But let me have you guys do numbers 8 and 10. I will write the question in the chat. Okay, so I'm gonna give you guys a few minutes to find your answers, draw it out, try to draw it out, and then the drawing part you can't really show me, but when I go over it, at least you'll compare it to your answer. Okay, but if you have any questions, feel free to speak or send me in the chat. Again, you can follow this example right here. Okay, does anyone need more time? Or any questions? I only have like one person sending me their answers. All right, 2 people. Okay, so I'm gonna go over the answers to number 8 and number 10. This is U, this is V. And if I have to add them up, yes, we have -3 adding a -2 and 2 adding a -1. We get -5,
Comma 1.
comma 1. Yes.
Wait, Ms. Yan, to draw it, we just use the points to make the triangle?
Yeah.
Okay.
So it should always look like a triangle. Let me see. -3, comma 2 is up here. So you usually don't have to do anything to U, but V is the one that we have to redraw. Let me see. This is V, right? So I have to redraw V to kind of make a parallelogram, and we draw it at the top. So this would be V. Okay, and then we're gonna connect from the beginning. Oops, use new color. Beginning to meet V. So this would be U plus V. Okay. Did anyone get this question right? Or the drawing part right? I know you guys would get the first part right. Okay.
Would the drawing be the same for 10 then, or would it be different?
It would be different because number 10, you don't have to redraw your V. Like you only need to utilize like this one and this one. Well, the first part is gonna be the same, but your final answer is it should kind of like shoot up from V to U for U minus V. Answer-wise, it's this, right? -1, comma 3.
Yeah.
Okay, and then this is U, this is V, and we start from V, and we go up to U. So this is how the answer looks like.
How come? It's because it's negative?
Because it's minus, yeah.
Or minus? Okay.
Yeah, so if you go back to my notes right here, the U and the V always start off at the beginning, like at the origin.
Mm-hmm.
But then we always start at the arrow of V to the arrow of U.
Okay.
Mm-hmm.
What does this homework do?
This homework is due on Thursday. We are almost done with the whole thing.
Okay.
Yeah. Okay, so I'm gonna go over number, actually, sorry, before that, let me finish going over the notes. So I finished vector addition and subtraction. Now we're gonna get into something called multiplication down here. Sorry. Oh, hold on. So there are 2 types of multiplication in vectors. One of them is called scalar multiplication, which is we have a vector, and then you have a number that you want to kind of multiply into the vector. So I have a number t, multiplying my vector. So the t is just going to arrow into each of these a and b, which we get ta and tb. Okay, so I kind of show an example down here. If we have a vector 2, comma 1, and if we want to multiply a 2 into the vector, you literally just do 2 times 2 and 2 times 1. So we get 4, comma 2. Okay? And then for if you have a vector multiplying a vector, this is something that you kind of have to remember now. You are doing something like distributive property. I mean, like the FOIL method. So we take the first times the first, so it's A times C, and then we add the last number times the last number. So it's A times C adding B plus B times D. Okay, so look at my example. I have 2 comma 3 and 5 comma 4. So I can multiply my 2 times 5 and 3 times 4, which we get 10 plus 12 equals to 22. Okay, so negative still applies. If you have a negative type of question, type of coordinates, you still have to multiply and you still get negative. So I have negative 3 times 4, adding 2 times 5, so it's negative 12 plus 10. Okay, so I will do number 6 last. Let me have you guys do number 14. Have this like that. Number 14, you are finding u times v if you have this being u and v is 2 comma negative 6. Okay, so go ahead and figure out your answer and type it in the chat for me. Oh, so fast. Someone already have their answers. Okay, so you guys are getting your answers. Negative 4 times 2, adding 5 times negative 6. Yes, it's negative 38. Okay, good job. Okay, now I'm gonna do number 6. So number 6 is a little bit different because they says find 2 distinct number b, so that if I have b times a vector, it equals to 4. Okay, so we kind of have to remember these lines right here. It means magnitude. We got to figure out the magnitude first, and then we set it equal to 4, because magnitude is a number. But if I have a number b, we want to multiply it into 3 and 7, negative 7. So it's 3b, comma, negative 7b. And if that's my vector, I'm going to have you guys do your square root. Okay. And we're going to square each of those x coordinate and y coordinate. So if I square the first part, what am I going to get? So feel free to say your answer out loud. If I square this first part.
Like square the 3b,
Yeah.
which would be 9b squared.
Mm-hmm. It would be 9b squared because I have to 3 times 3 and b times b, right? So 9b squared. How about the second part?
Plus 49b squared.
49b squared equals to 4. Okay. And then since those b squares are like terms, we get 58b squared with a square root equal to 4. Okay, almost done. What do you think we have to do? Yeah.
The square root and the square cancel with the b, right?
Only if 58 it's a perfect square.
Oh, okay.
Yeah, so what do you think we have to do if we can't cancel it out like that? We still have to get rid of the square root. We have to get rid of square root first. We can square both sides.
Mm-hmm.
And then we cancel out the square and square root. I'm going to bring it up here. We have 58b squared equals to 16. Okay. Divide both sides by 58. So I have b squared equals to 16 over 58. Okay. Last step. We
Would the
can
answer be 4 square root 58 or 58?
positives and negative of it. Because we have to find two answers, right? So, yep. B's get canceled out. So I have b equals 4 over square root of 58 plus or minus. But since we cannot have square roots at the bottom, it will be 4 square root of 58 over 58. And yay, we're done with our